Hello students. So today is our second class on mean, median, mode and quartiles, the central point of tendency. So in the first class already we have covered the concept of mean, median and mode. I hope you understood that, and those who have not seen the video, I would request you to look into the link in the description section below for this particular video. The first video where I have given the concept of mean, median, mode. Go through that video and then you come to this second class on central point of tendency, mean, median, mode and quartiles. Okay, so what we are going to cover today? We are going to cover today only mean, but the detailed about mean calculation. It could be the methods to derive mean. There are three different methods: direct method, shortcut method, step deviation method. Direct method, I have not mentioned the name though, but the direct method actually we have covered in the first day to understand mean calculation or how to derive mean, what is mean. So still I will cover that direct method, then shortcut method and step deviation method, and where to apply which method. Why there is a need to understand all these three divisions, all these three methods to derive mean and where to apply which one. And also based on the different values, the discrete values or the class intervals. I will tell you exactly what is class intervals, right? Okay, let's go. Okay, so first we are going to learn what is direct method. How to calculate mean using direct method and where to apply direct method. So if you remember in the first video already I said that you can have all the data observation. Observation means the values and how many times those values are there, the occurrence of each observation, those are their respective frequency. So either the number could be given like this: 2, 5, 6, 9, 2, 5, 3. So here you can see of number of observation, observation 2 is there for 2 times. Observation 5 there is for 2 times. But 6, 9, 3, these observation values, those are just for once. So you can have this entire set of values in a tabular form where you can have all the observation values here x, that is 2, 5, 6, 9 and 3, and in the respective and the second column for each of the observation you can have the frequencies f, like 2 you have twice, 5 you have twice, 6 you have once, 9 you have once, 3 you have once. That already I have explained to you in my first video, how to calculate mean and what is mean exactly. So that tabular form, the data here I have given in a tabular form. Okay, so here in this particular table if you see, there are total, if I add up all in the first column you have the observation. What is observation? The problem is you have total 40 students in a class where, or in a teaching in a tutorial where the age of the students, those are given. So 12 years age, 2 students, frequency, second column, frequency 2. There are 4 students having age 13 years, 6 students, frequency, having age 14 years, 9 for 15 years, 8 students having age 16 years, 7 students having age 17 years, and 4 students having age 18 years. So in the first column you have all the observation values, those are age in years, and in the second column the respective frequency against each of the observation. These are given values. Now how to derive the mean? All these columns, where basically for direct method you need only 3 columns. So first one, second one and third one, you will come to know about these columns when I will explain about shortcut method and step deviation method. So first you need to have the observation, you need to put all the observation. There is no need to put the observation in the shorted manner, though it is in the shorted manner here in the table, but in mean calculation you don't need to arrange the observation in shorted manner. You can in any order, you don't need to mention, just you need to write down all the unique values in the observation in the first column, and then the respective frequency against each of the observation values. Now what I need to do for direct method, simple thing is that what is the formula of mean? The formula of mean is mean equals to sum of all the numbers, sum of numbers or observations. Numbers means sum of all the observation on numbers divided by total number of observations. That is, the formula equals to sum of numbers means each of the observation value x into their respective frequency f. That means summation of xf divided by summation of total number of observation. That means total number of frequency, total number of students in this case, that is summation of f. That portion you need to find out here. So here x is given, f is given. For each of the observation you find out the fx. Multiplication. For each of the observation multiply with their respective frequency, because rather than writing the observation 12 plus 12 plus 13 plus 4 times 13, 12, 2 times 12, 6 times 14, you will not sum up the numbers like this. Rather what you will do, 14 6 times means 14 into 6. 12 2 times means 12 into 2. That's how, right? So fx, that here it is 12 into 2, that is equals to 24. Here it is 13 into 4, that is equals to 52. Here it is 14 into 6, that is equals to 84. 15 into 9, that is equals to 135. 16 into 8, that is equals to 128. 17 into 7, that is equals to 119. And 18 into 4, that is equals to 72. Where you can find out the fx, the way numbers are given, it is very much, you can calculate it easily. There is no complexity in the calculation part. By multiplying these two, there you will apply this direct method, because all these are simple calculation. There you don't need to apply shortcut method or step deviation method. That means where you have enough number of data, let's say the frequency that is very high, let's say it is 252, instead of 2 it is 252, instead of 4 it is 792, then multiplication, it's bit complicated. There you should not apply direct method. But here where the calculation is very easy, there you will apply direct method. That means the frequency is not huge. That means the number of data points or observation, those are not too high. Here what is the number of observation? Total frequency, that is summation of f equals to 2 plus, as I said already, 40 students. Still you see 2 plus 4 6 plus 6 12 plus 9 21 plus 8 29 plus 36 40. So total number of observation summation of f, that is 40. Here you need to find out summation of fx. How much it is? So the summation is 614. So summation of fx, that means the total, you sum up all the numbers. So how to find it out? All the observation multiply with their respective frequency and then sum up. So summation of fx, it is 614. So now you put this value here, 6 summation of fx, that is 614 divided by summation of f, that is the total number of observation 40. If you calculate, it will be 1 5 3 4 120 3 and 5. So mean means average age of the students in that class or tutorial. So what is the average age? If such tabular form is given, you are asked to find out what is the average age of the students in that case. That's average means arithmetic mean. That is the average. So arithmetic mean on average age of the years of the students is 15.35. That is what direct method. And where you will apply, where the calculation is very simple. Now I will explain you shortcut method and where you should not go for direct. And sorry, now I will go for you. This is the discrete values. There is a direct method for discrete values. Now I will go for class interval. What is class interval? And then the same direct method I will apply for the class interval. Then I will go to shortcut method. Okay, so in this example, just look into this table. I have given in the first column, this is a range of marks. In an exam, let's say for 20 to 30 marks, in between 20 to 30 marks that is obtained by 10 students, that is in the second column, that is the frequency. 30 to 40 marks obtained by 6 students. 8 students obtained marks 40 to in between 40 to 50. 12 students scored in between 50 to 60. 5 students scored in between 60 to 70 marks, and 9 students scored in between 70 to 80. Now you are asked to find out what is the average marks by the students of this particular class. What is the average marks? Average marks means actually it is mean. Average marks means mean. You need to find out mean. And here you can see I have not told that 20 marks has been obtained by 10. It is a range is given. This is what this, when the group data, you have the number in bucket or in a range is given. That is what called class interval. So this 20 to 30 in the marks itself, class interval. This is called class interval, or in short form it is CI. That is why in the first column under marks I have given, write down C.I. class interval. These are the class interval. In the direct method, what we are doing, since there was no range given, straight away we are multiplying the observation values with respective frequency and writing down in the last column itself. But here I have not marked these fx. X is somewhere else. X is not this one. This is just the class interval. We need to deduce the value of x. That is the average marks for each class interval. You need to find out the average marks for each class interval. So for this particular class, this is what actually here x. For class interval, you need to find out the average marks for each class interval. That means 20 plus 30, that is actually 50. 50 by 2, 25. So what is the average mark for this particular class interval? It is 20 plus 30 by 2. This is what the 20 plus 30 by 2, that is equals to 25. Here it is 30 plus 40 divided by 2, that is equals to 35. Here it is 40 plus 50, 90. 90 divided by 2, that is 45. 50 plus 60 by 2, that is 110 by 2, that is 55. 60 plus 70 by 2. So average marks for each class interval you need to find out when the class interval kind of question is given to derive mean, right? 60 plus 70 by 2, average marks for this particular class interval, it is 130 by 2, that is 65. And what is the average marks for this class interval? That is 70 plus 80 by 2, that is 75. Now you need to multiply frequency for each of the average. Here you have, these are calculated. You have calculated this average for each of the class interval. You need to multiply with the respective frequency. Now 25 into 10. So how you will do it? 25 into 10, that is equals to 250. Similarly 6 into 35. that is 210. So this is what the last column in for discrete values only, this isolated number, there you have just directly multiplied the frequency with the observation value. Here you need to find out the mean against each of the class interval, then you need to multiply with the respective frequency for that particular class interval. So now you need to sum up. Now you need to sum up this one, because you need to find out summation of fx, and here you need to find out summation of f, that is the total number of observation. How much it is? 10 plus 6 16 plus 8 24 plus 12 36 plus 5 41 plus 9 50. So total number of students is 50, and then total number of, this is the total score, right, obtained for the class interval. How much it will be? You sum up this. So the total summation is 2480. So what is the average marks? Average marks equals to summation of fx divided by summation of total number of students, total number of observation, that is total number of students, summation of f. That means 2480 divided by summation of f is 50, that is 50, that is equals to 450 200 480 49.650. So average marks is 49.6, that is the mean, right? So this is what your answer. So for class interval you will find out the mean. For direct method, when you will calculate the mean through direct method, there you need to find out the mean, right? And from that mean itself, then you need to multiply with the respective frequency, and then as it is. Okay, then we'll move towards shortcut method. So now you understood how to apply direct method for discrete values and class intervals for these two examples. And for direct method, actually where the calculation is simple and the number of students means number of observation. Actually in statistical term it is number of observation. Number of observation is not very high and the calculation is simpler, then you will apply the direct method both for class interval as well as isolated values. Okay, so in the earlier example for the class interval, what I have shown you, that when the class interval is given, then you will not multiply with the frequency straight away. You need to find out average for each of the class interval. But for non-grouped data, ungrouped data, that means where there is no class interval, just the number is given in the observation, there straight away you will multiply with the frequency and you will fill it up in this particular column, fx. So that is how the direct method. So direct method we have shown already for class interval as well as for the isolated or ungrouped data. Here we are going to explain shortcut method. So shortcut method also I am showing it for the class interval. The same thing you will apply also for normal ungrouped data also. There you don't know only the difference. For ungrouped data, straight away you will take the number from this column, from the observation value. But for grouped data, you need to find out the actual observation values by taking the average for each of the class interval. So for group data, your multiplication of the next process will start from after calculating this average value for each class interval, or for ungrouped data your calculation will start straight away from this particular column where the direct number will be, or isolated number, ungrouped data is discrete number is given, right? So for shortcut method, what we will do, you have seen already for using direct method, we have gone through a bit bigger number, that is 2480. But I will show you, even though the number is total observation is 50, then also if you go through shortcut method, the calculation will be much easier. How it will show? You need to assume one mean from the given observation if this is not ungrouped data, and for class interval, after deducing the average for each class interval, you will assume the mean. Assume the mean value, one of them, any one of them. I am taking in between values somewhere, not the starting value or the lowest value or the biggest one. In between value. Let's say I am assuming 45 is the mean. Assuming, this is not the actual one. So I am assuming, assume mean A is the mean. Assume mean A equals to 45. So you assume from the given values or from the calculated values for class interval, right? So assume mean is A45. Now you need to find out the mean deviation. This is called mean deviation. If this is the assumed mean, then how much is the deviation, right? So that you need to calculate. How you will calculate that? You deduct the assumed mean from each of the observation, or for class interval from the average mean. This is actually the average mean. This is average mean for class interval. Per class interval. This is not average mean for entire group. Per class interval. So average, assume mean A45 and then deduct it. That means 25 minus A equals to minus 20. 35 minus A equals to 35 minus 45, that is equals to minus 10. 45 minus 45, that is 0. Because you are, see, from the average mean you are calculating for direct method straight away with the number of students. Here you are deducing this number further, you are reducing it so that your calculation will be much easier. So 25 comes down to minus 20, 35 comes down to minus 10, 45 comes to 0, 55 minus 45, that is 10, 65 minus 55, 45, that is 20, 75 minus A, that is 75 minus 45, 30. Now you will multiply this frequency with these numbers, not this average mean. So this shortcut method, actually what you are doing, that you are finding out the mean deviation. This is called mean deviation. This is a very much important concept whoever will go for statistics analytics or statistical data analysis or the error calculation. If you go through AI or machine learning, this is mean deviation that is very much important with respect to error calculation. Mean deviation. That you will not understand right now. Just this term you remember, error calculation. There you find out mean deviation. So mean deviation actually you are finding out. Assuming one mean, then what is the deviation from the actual observation. So this is how. Now you will calculate. So this is what, this particular column I am marking it as D. That is mean deviation, D for deviation. And here you will not fx, you will have fd. So now you will calculate fd, second column with fourth column. So 10 into minus 20, minus 200. Right? 6 into minus 10, minus 60. 45 in 8 into 0, 0. 12 into 10, 120. 5 into 20, 100. 9 into 30, 270. Now how much is the total calculation? What is the summation here? Summation of FD equals to 270 plus 100, 370, 370 plus 120, 490. 490 minus 200, that means 290. 290 minus 60, that means 230. So for step deviation method, what is the formula of mean? Mean equals to the assumed mean A plus, instead of summation fx, here we have done fd. So summation of fd divided by summation of F, total number of observations. So how much is A? A equals to 45. And what is this value? 45 plus summation of FD means 230 divided by 50. So 45 divide plus 230 by 50 means 4.6, that is 49.6. So this is what the mean through step deviation. So the same value got from direct method and this value got from step deviation. Only the difference is that you need to assume one mean from any of the given values or in observation, or for class interval it will be from any of the average mean for any of the class interval. Then you find out the mean deviation, how much the mean is deviating from the observation, and then you multiply with the respective frequency, and then as it is. Only the difference here again, it is here you will find out not only straight away summation of FD by summation of F. Here you need to add up that value with the assumed mean A. So this is what stepped shortcut method. Okay. So now we are coming on the third method, step deviation method. So for the earlier table for shortcut method, what I have explained for shortcut method, the same table I have kept here with the same observation values of the class interval. I am giving you this step deviation method. I am explaining you with respect to class interval. If it is not with respect to group data or class interval, there straight away we will start it from the given observation value rather than finding out the average mean for each of the class interval. That is the only difference. Rest are all same. So I am explaining the same thing, same for the same class interval, the step deviation method. So step deviation method up to the mean deviation, all the steps you need to do up to the mean deviation, up to this step, this is absolutely same like the shortcut method or mean deviation that you need to calculate. What is the extra step you need to do for step deviation? So now what you need to do, you need to find out the biggest number from this D, from this deviation. What is the biggest number that can divide each of the deviation? That is, each of the deviation is divisible by which maximum number, that is actually I. So that by that value you need to divide the D, that is called T. So you need to find out T, where I is the maximum number which can divide each of this deviation. Here you can see, so minus 20, 10, 0, 10, 20, 30. So which number, by which number if you divide all these numbers, that is absolutely divisible, that is 10. So I equals to, actually in this particular case, I equals to 10. So it depends based on the values here, you need to find out I. So now if you divide this one, this is minus 2, this is minus 1, this is 0, 10 by 10 1, 20 by 10 that is 2, 30 by 10 that is 3. Now what you need to do, you need to multiply with the frequency with this table. Earlier what you did for the shortcut method, you multiplied this frequency with the deviation. Here you will multiply this frequency with this T. So how much will be the value here? Here it will be 10 into minus 2, that is equals to minus 20. Similarly, it is minus 6. It is 0. 12 into 1, 12. 5 into 2, 10. And 9 into 3, 27. So altogether, how much the value is coming here? 27 plus 10, 37 plus 12, 49. 49 minus 20, it is 29, minus 6, that is 23. Summation of Ft equals to 23. Now, what is the formula to calculate mean or average using step deviation method? So, mean value will be the formula is mean equals to assumed mean as it is, like the shortcut method A plus, here it is summation of ft, instead of fd for shortcut it is ft by summation of f into I, which number you have multiplied, actually by which number you have multiplied, that is what you need to do here. So it is 45 plus 23 by 50 into 10 equals to 45 plus 23 by 10, 50, this is 5, so 4.6, it is equals to 49.6. So that is how the value through step deviation method. So on top of direct method, for shortcut method we have found out the deviation from the observation. If this is class interval, you need to find out the observation value by finding out the average mean for each class interval. Otherwise, for ungrouped data, it is straight away you will assume the mean from the given observation. For class interval, you need to find out the average mean for class interval, that is you will treat as the observation values. Then you will assume one of the mean from the given observation values of the for the average mean, and from the average mean, and then you find out the deviation of that mean deviation for each of the class interval or for each of the observation, and then you multiply with the frequency to that d for shortcut method. But for step deviation method, what you will do, you need to do another step where basically you need to find out the value of I, by what you can, all the deviations, those are divisible. Maximum value of I, that is you need to find out by what all the division values are divisible, and then you will multiply this t value with the frequency. This is very simple. Just you need to find out the remember the frequency, and only the difference here, finding out the mean for this step deviation than the shortcut method. Here it was fd, division value with the frequency. Here it is t, summation of ft, and you need to multiply with I, for which value actually you utilize to divide all the deviation. And that is it. I will take another class where basically I will do few of the examples for mean. Here I have explained you what is class interval, how to utilize direct method, shortcut method, and step deviation method, both for discrete values and class intervals, and where you will utilize which method. It is just one thing you remember, for the simplicity of calculation, where huge number of observations are given. Here I have shown you even for 50 observations, but actually the utility is where direct method is pretty much critical. Direct method, if you apply direct method, for the complicated calculations, that will be difficult to do the calculation part itself. It is only for the calculation part. For where there you will apply shortcut method, and for shortcut method, it is much easier also the calculation for step deviation method. That you need to apply your discretion where you will apply, but the generic rule is where the calculation is very much complicated or the number of observations are very high, there actually you will apply either shortcut method or step deviation method based on the case, based on the use case. Okay, so I hope you understood all these methods and the class interval also. So if you like it, please click on the like button, and please subscribe the channel if you would like to have this kind of video again and again, and to clear your fundamentals. Okay, thank you very much.